Hello, hello, hello everyone. So if anyone is there, then please comment me if the voice is okay now. I think you will not get any voice, so please comment me just once that the voice is okay, because I am forget to connecting my mic. Okay, so this is the case. Anyone is there, please comment me. I think now voice is okay. Okay, just a second, I will check once. Voice is okay. Is anyone is there, please comment me. Please comment me if the voice is okay, please. Just a second, I will check once, because I don't have any mobile. Okay, voice is okay na? Thank you Nargis for commenting.
फैमिली के डीटीएच और केबल टीवी रिचार्ज घर बैठे।
Voice is okay na? Okay. So hello everyone, this is Chandan. Thanks for visiting my channel. So in this video we are going to solve the questions paper of WBSET 2023 which happens in the 8th January 2023, and in this session we are going to solve these questions from ODE, from PDE, from LPP, from numerical analysis, from integral equation. Okay, I think in this video I will cover these questions. Okay, so let's start, and before starting I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel. Okay, so let's start to solve the questions. So the first question is this one. So this is the question. This question says that initial value problem dy dx equal to cos xy. That is, the question is given dy dx is equal to cos of xy, and I'll share the question paper of X series. These numbers, this is question number 18, which is from X series. Okay, so this is the question series from X questions from X series. Okay, so cos xy. Okay, where y at 0, this is equal to y0. Okay, so how can we solve these questions? Okay, so first, just a second. So this is, suppose dy dx equal to fxy. Now if fxy, this function satisfies the Lipschitz condition, then this differential equation or this initial value problem has what? The unique solution. If this is this does not satisfy the Lipschitz condition, then it has infinitely many solution. Okay, and one more condition is that if del f del y, this is bounded, these terms we can write these terms, this type of terms, that is del f del y is bounded, then this implies this f satisfies what? The Lipschitz condition. Okay, Lipschitz condition. So just we check whether this function's cos of xy satisfied the this term or not. Okay, so cos of xy, suppose f of xy, this is equal to cos of xy. Okay, so that means del f del y, this is equal to minus sine of xy into x. Okay, now this is not bounded because this x belongs to R. Okay, since x belongs to R, that means x can take any value from the real number. That means this del f del y is not bounded. Okay, so since this fxy is not bounded, then this does not satisfy the Lipschitz condition, and if this does not satisfy the Lipschitz condition, then this initial value problem has infinitely many solutions. C option is correct here. Okay, now going to the next question. This question again from ODE. Okay, from the chapter eigenvalue problem. So this is question number 19. Okay, from X series. So the eigenvalues of the boundary value problem, d2y dx2 plus lambda y, this is equal to 0, x belongs to 0 pi, where y0 equal to 0 and y pi minus y dash pi equal to 0 are given by, these are the 4 options are given. Now the question is y double dash plus lambda y, this is equal to 0. Okay, and y0 equal to 0 and y pi minus y dash pi, this is equal to 0. Okay, now since we all know that this solution of this solution of this eigenvalue problem, how can we write the solutions? So y equal to a cos root lambda x plus b sine root lambda and y. Okay, so this is the solution of the problem, we can easily write. Okay, so now we apply y0, this is equal to 0. You can also check by using the auxiliary equation, that m square plus lambda, this is equal to 0. This gives m equal to plus minus iota root over of lambda, and from the value of lambda we get this solution for the value of m. Okay, so this is the solution, and y0 equal to 0 implies what? 0 equal to a plus 0. That means what? A equal to 0 here. Okay, now if a equal to 0, therefore y equal to what? B sine root lambda y. Okay, so this is the case, and y dash, this is equal to what? Root lambda b cos root lambda y. Okay, so this is the value of y dash. Now we apply the second condition, that is y pi minus y dash pi, this is equal to 0. Okay, now if from here we can write, if b equal to 0, then this y equal to 0, and we get the initial solution or the general solution or basic solution, initial solution, but we are interested in a trivial solution. Okay, but we are interested in non-trivial solution. That means here b is non-zero. Okay, then b is non-zero means what? B sine, we can write the sine root lambda y, this is equal to 0. That means what? Lambda equal to, sorry, I get a mistake here. This is not case, not the case. Okay, oh sorry, it is right. So sine root lambda y, this is equal to sine n pi, you can write root lambda, sorry, this is not the case. So first we apply this condition. Okay, so y pi means what? Y at pi means what? Here y pi means b sine root lambda y. Okay, and minus y dash pi means b root lambda cos of root lambda y. So this is equal to 0, and this 0. Now if we take b equal to 0, if we take here b common, so sine root lambda y minus root lambda cos root lambda y. Okay, so this is equal to 0. Now if b equal to 0, then this gives against the trivial solution. Okay, therefore b must be non-zero. Okay, now b non-zero means what? This quantity is equal to 0, this quantity. That means what? We get sine root over of lambda y minus root lambda cos root lambda y, this is equal to 0. Okay, so this means if we divided it by what? By cos root lambda, then we get here, this is tan root lambda y, or these are pi's, sorry, because this is the function of pi. So this is pi, this is also pi, this is not y, this is pi, this is so pi. Okay, so sine root lambda pi minus cos root lambda cos root lambda pi equal to 0. This means tan root lambda pi, this is minus root over of lambda, this is equal to 0. Okay, so now that means what? These are the equations of what? This type of equation, k minus tan root k pi is equal to 0. If we take k equal to root over of lambda, okay, that means what? K square equal to lambda. Therefore we can write from this equation, we can write tan of k pi minus k, this is equal to 0, or k minus tan of k pi equal to 0, or lambda equal to k square or kn square. Okay, so this is the correct answer, option D here. Statics. Okay, yes, Nargis, but in this video I will cover these questions only. I am not taking the others question in this session. We will take another sessions and solve the questions as you say. Okay, so now we are solving the third questions of ODE, which is from Wronskian. Okay, so see, the question says that the Wronskian of the function f1 equal to x square and f2 equal to x mod x. So now if we calculate f dash equal to 2x and f2 dash, this is equal to 2 mod x. Okay, we just simply calculate the Wronskian, then this gives x square into x mod x into 2x and 2 mod x. Okay, so this implies now this is equal to what? If we calculate the determinant of this Wronskian, then we get what? 2x square mod x minus 2x square mod x. So this is clearly 0 for any value of x. Okay, so that means the Wronskian is 0 for all value of x. Okay, so this is the answer of the question number 20 of OD, which is option A. Okay, now going to I skip this question. This is the questions from Green's function. I will solve this question next time. Okay, now if we solve the question number 41, this is from PDE. Okay, and this is a very easy question. The question says that if x the solution of x ux plus y uy equal to 0 is the form of what? F of these 4 are the options. So this is the questions we are solved using the Lagrange's method. Okay, so x ux plus y uy, this is equal to 0. That means the Lagrange's auxiliary equations are dx by x, this is equal to dy by y, this is equal to what? Du by u, du by, here this term is 0. Okay, so now du by 0 gives, this implies first give u equal to constant, suppose c1. Okay, now from these two ratio we can write log of x, this is equal to log of y plus log of c2. Okay, so we can write log of x by y, this is equal to log of c2. So this implies we can write x by y, this is equal to c2. Now the solution of the system can be written as in the form of c1 equal to f of c2. Okay, so this implies c1, this is equal to f of x by y. Okay, so this is very easy question, that is the option question answer is option number A, in the form of f of x by y. Okay, now going to the next question, question number 63. This is also from partial differential equation. The question says that if the partial differential equation x minus 1 whole square into uxx, x minus 1 square uxx minus y minus 2 whole square uyy plus the first order terms we are not required here. So we just need this second order derivative terms. So this is, we all know that r, this is t, and the coefficient of uxy is s, but which is not present here. That means we here calculate the term s square minus 4 rt, and it says that it is parabolic. That means what? This terms is equal to 0. Now s square is not present here, therefore minus 4 into r means what? X minus 1 whole square into minus of, this is minus of y minus 2 whole square. Okay, so this is equal to s square minus 40 term, this one. Okay, so this is equal to 4 into x minus 1 whole square into y minus 2 whole square. Now this term will be 0 for what value? For x equal to 1. If we put x equal to 1, then this term goes to 0, or if we put y equal to 2, then this term is also 0. Remember, this is OR, because the both value of x and y are not required to provide this term equal to 0. Okay, if we need just one value for either x or for either y, then we get this term equal to 0. That's why this OR will be the answer. Okay, that means the correct answer is option A here. Okay, so this is the question number 63 and from PDE, and the answer is option number A. Okay, so now we going to the next question. Question number 5. This question is from LPP, and this question number series are from X series questions paper. This is the X series question paper. Okay, so those who are watching the session, please give a like to this video, or please give a like to this session. Okay, so question number 5 says that if x is a feasible solution to the primal, then maximum of z equal to cx. So the primal problem is this: max of z equal to cx subject to the constraint ax less equal to b. Okay, x greater equal to 0, and v be the feasible solution of the dual variable, and the dual problem is what? A minimum of u, this is equal to b transpose v, where subject to the condition, subject to what? A transpose v is greater equal to c transpose. Okay, so this is simple primal variable, primal solution, and the dual. Okay, so these are the provided in the questions, and it says that then what happened in between the 4 options. Okay, so this is very easy question, and we can always say that the objective value, the optimal value of the objective function is equal for both the case, that is the case of primal problem and the case of dual problem. Okay, but here we have another theorem which says that that is the weak duality theorem, says that always remember this thing: this is the minimization value of the objective function of the minimization problem is always greater equal to the maximization problem. When I take the class of LPP for gate or set or CSIR net, in my lecture series of LPP, this theorem is available. Okay, you can check, and the playlist is available in my channel. So this is very helpful playlist for LPP for the upcoming gate exam. Okay, so weak duality theorem says that always remember this thing, then you can't forget this. Okay, and any questions comes based on this theorem, you can always answer the questions in a correct way. Okay, so this is the questions. That means what? Always minimize the value of the objective function of the minimization problem is greater equal to the maximization problem. That is here the minimization problem is the dual problem. That is what b transpose v is the value of the objective function of the dual. That means b transpose v is greater equal to the objective optimal value of the objective function of the primal problem is cx. So this is the answer clearly. That means what? I think option C is correct here. Okay, so this is the question, directly theorem based question, and this is the application of weak duality theorem. Okay, so now going to the next question, and the next question, question number 6. This is again from LPP. Okay, this is again from LPP, and this is the question paper of GATE 2018. I already solved in the playlist of my GATE playlist, of my LPP playlist. In my LPP lecture series, all these types of questions are available. Okay, so this is very easy questions if you solve this question. So the question says that consider the linear programming problem, and also the concept of these questions is all is covered by me in this channel or in the playlist of LPP. Okay, you can I must say that you can check the playlist of LPP. Okay, So consider the linear programming problem, maximization of alpha x1 plus x2 subject to the constant. These three are the constant, where alpha is the constant. If 30 is the only optimal solution, then which of the following is correct? So this is the application of complementary slackness theorem. I already covered this theorem in my lecture series of LPP. Okay, so complementary slackness theorem says that if the optimal solution of the primal, this one, satisfies this any of these inequalities with its strict form. That means if we put the value to this constant and the inequality gives its strict form, that means what? So suppose if we put in the first inequality, that means 2 into 3 plus 0, this is equal to 6, which is less equal to 6. This type is not valid. That means if we put in the second, so minus of 3 plus 0, this is strictly less than 1. So if the strict inequality holds in the constraint, then the corresponding dual variable is 0. That means what? If we take y1, y2 and y3 as the dual variable, then if we put the optimal solution of the primal problem in this condition or constant, then this second inequality gives the strict form. That means the second dual variable is 0. That means y2 equal to 0. Now if we put the optimal solution in the third constant, then this third constant is also give 3 plus 0, which is strictly less than 4. Okay, that means the third dual variable is also 0. That means y3 is also 0. Okay, now this is the case, and another part is of this property or of this theorem is that if this non-zero solutions occur in the optimal form, then the corresponding dual constant gives the equality. Since the first variable is non-zero here in the optimal form of the primal problem, then the first dual constant is equality type. Okay, so if we write the dual of this variable, dual of this problem, then so simply we can write 2y1 minus y2 plus y3, this is greater or equal to alpha, and y1 plus y2 plus y3, this is greater or equal to 1. So these two are the dual constant. Now this x1 is non-zero. That means this inequality is strict equality. That means 2y1 minus y2 plus y3, this is equal to alpha. Now y2 and y3 are 0. So this implies what? Simply 2y1 equal to alpha. Okay, 2y1 equal to alpha. That means y1 equal to what? Alpha by 2. So this is the value, y1 equal to alpha by 2. Okay, now if we put this to the the optimal form, that is what? 6 just a second. If we put y1 equal to alpha by 2. Okay, so now the objective value of the dual problem is what? The objective value of the dual problem is, so 6y1 plus y2 plus 4 y3. Okay, so this is the objective value of dual. Okay, objective value of the dual. Now if we put the values of y1, y2 and y3, then this is gives what? 6 into alpha by 2 plus these terms are all 0. That means this is equal to 3 alpha. Okay, now what? This 3 0 is the optimal solution of the primal problem. That is the objective value of, that is z equal to what? 3 alpha plus 0. I think this one, 3 alpha plus 0. Yeah. Just a second. I think I am doing a mistake here. Just a second. Just a second. Question number 6. Now what weak duality theorem says what? I think if we apply weak duality theorem here, then this gives 3 alpha is less, sorry now if we put this value y1 and y2 and y3 to this inequality, simply we can get our answer. Okay, so this gives alpha by 2 plus y2 and y3 value as 0, so 0 plus 0, this is greater or equal to 1. That means what? Alpha is greater or equal to 2. Okay, so this is another way, and we can also, I think, apply here the weak duality theorem also. So you can check the GATE 2018 solution paper. Okay, in that video I is equal to 0. So this question, in this question the answer is already provided. Okay, what integral equation has not dummy data, because you have to check whether this is a Fredholm integral equation and whether it is a Volterra integral equation. And we all know that if the limit of the integration are constant, then this is a Fredholm integral equation, and if the limit of the integration are variable, then it is a Volterra integral equation. Okay, so it has no characteristic number. Okay, characteristic number means characteristic value or eigen value. Okay, so this is the case, and this is the answer of the problem. Okay, going to the next question, question number 59, and this is again from integral equation. So it says that y(s) equal to s plus integration 0 to 1 s u square yu du, and then the value of y3 is so we can write the integral equation yx equal to, since we write here mostly x and t, therefore you can simply convert, or I also simply convert this integration with the variable x and t. So this is equal to x plus integration 0 to 1 into x into t square yt and dt. So this is the integral equation, and this is again a Volterra integral equation. And how can we solve this equation? So we first write c equal to integration 0 to 1, this is the integration with respect to t, so t into yt, and sorry, this is t square, I think, yeah, t square yt and dt. Okay, so yx equal to, we write here x plus cx, so yt equal to what? T plus ct. Okay, t plus ct. Now we put the values this yt to this c, so c equal to what? Integration 0 to 1 t into yt means t plus ct into dt. Okay, so this is equal to, sorry, t square, this is the term t square, yeah, t square. Okay, so this gives simply tq means t to the power 4 by 4, that means 1 by 4 plus 1 by 4 into c. Okay, so the value of c we find from here, and the value of lambda here is equal to 1, because lambda is present in here, so here lambda is not present, that means the value of lambda equal to, we can say the value of lambda equal to 1 here. Okay, so that means what? 3 by 4 c equal to 1 by 4, this gives c equal to what? 1 by 3. Okay, now from c equal to 1 by 3 we put the value of c to this equation, so yx equal to what? X plus 1 by 3 into x. So this is the solution, and we have to find the value at x equal to 3, so y at 3, this is equal to 3 plus 1 by 3 into 3, so this gives 3 plus 1, this is equal to 4. This is very simple question, so D is the correct answer here. Okay, now going to the next question, and this question is from numerical analysis, question number 54 from X series. Okay, so consider the series xn plus 1 equal to xn by 2 plus 9 by 8 xn n equal to 0 1 to n with x0 equal to 0.5 obtained from the Newton-Raphson method. The series converges to what? So see, in this question you don't have any calculator to calculate the Newton-Raphson method. Okay, so if you calculate the terms of Newton-Raphson method, then this question is going to very big questions, or the calculation is also laborious calculations. Okay, so to skip the calculations, what we can do with this question? Okay, we do not apply here the Newton-Raphson method, you simply apply what? This type of questions in real analysis. How can we solve this question? So simply we write L equal to L by 2 plus 9 by 8L. Okay, so we can simply write this. So this is equal to, this is the way to save your time in the exam hall. Okay, so 8l and this gives 4l square plus 9. Okay, so 8l square, this is equal to 4l square plus 9 here. This implies 4l square equal to 9, and this gives l equal to 3 by 2, that means 1.5. So this is the answer, 1.5. Therefore the series converges to 1.5 simply. See, if you apply the Newton-Raphson method to this problem, then this problem is going to be a very big or very laborious calculation. Okay, so we have to solve this problem by any way. Okay, and you do not have any calculator in the exam hall, so you can't apply the Newton-Raphson method to solve this question. Okay, I think this is the very easy way to solve this question. Okay, so this is answer, 1.5 is the answer of this question. Now going to the next question. This is very easy question. So the question says that the trapezoidal rule for evaluation of integration a to b fx dx, it requires the interval ab to be divided into what? So to be divided into and we know that there is no restriction in the trapezoidal rule to divide the intervals. Okay, so here simply the correct answer is this one, any number of subintervals of equal width. Okay, so if you see the trapezoidal method, there all the books use the n subintervals. What is n? N is any number. Okay, what is trapezoidal method actually? So trapezoidal method is actually area under the curves, by dividing the area into smaller trapezoids, into SMALLER, smaller trapezoids, or rather rectangles. So this is the trapezoidal rule. I think it is the motto of the trapezoidal rule, and we can apply we can take any number of subinterval in the trapezoidal rule. Okay, so I think this is the last question. So this is the last question for today's session. Okay, so here I think we solve 10 to 12 questions. Okay, so we solve here the questions from ODE 3 questions, PDE 3 questions, numerical analysis 2 questions, LPP 2 questions, and what are the remaining questions? Integral equation, integral equation, I think integral equation. Okay, integral equation 2 questions. Okay, so I think 3 6 12 questions we solve here in this session. Okay, so if this session is helpful, then please give a like to this video, share with your friends, and subscribe the channel. We will solve the questions paper one by one. Okay, topic wise I am trying to provide the solutions topic wise. Okay, so here we take mainly the applied portion, and after that one by one we are solving, or we solve the all papers. Okay, so thank you for watching. Thank you, and those who are new, please like the session and share with your friends and subscribe the channel. Thank you friends, see you again in the next video. Thank you.